Hey, great. So let's go. Let's move on to number 10. I noticed that I had 19 on there. Oops. All right. So I just changed it to unit 10, law of sines. So, okay. So again, I want to reiterate that a lot of times math looks difficult, but really, in essence, math is using skills that we already know. So, for instance, I know since we started this lesson that you guys know how to do um, solve proportions. Meaning, if you have two equal ratios, oops, oh, you're going to see a big fish here. Yeah, not mine. Uh, so, if you have two equal ratios, um, we do the cross multiplication, and then we can find the unknown. So, you know how to do that. One thing I love about math, one thing that just makes me really well, one thing I think makes math creative is that we can apply any knowledge that we know to solve any problem that we want to solve. Once you know something in math, there's no exceptions to it. It's always true. It's something that we can count on till the end. When you're teaching your kids about proportions, the same facts apply today that I'm teaching you right now that will apply when you're teaching your children how to do proportions. They don't change. Now, we can be as creative as we like. We can apply this knowledge to other problems in ways that maybe other people don't have thought of, but it will always be true. Okay, so I'm going to start by giving you a couple formulas. Now, I know I said this law of sine. I get this little speech about about past knowledge. These are some formulas that we can use to start with. Some area formulas that will find areas of any triangles when I don't know. Normally, I need a base and a height, and if I don't know the height, I can find values knowing these pieces of information. So here is so we all know that the area of a triangle. This is true, and it always has been that the area of a triangle is 1/2 base times height. But we can also use another formula, and if I don't have this information. So here is some things that we can also know about. So let me just draw you this random triangle up here. Label these vertices as A, B, and C. And just for argument's sake, if I was standing on A and looking at this opposite side, I'd call this little a. Now, it's not a right triangle, so I don't have opposite, adjacent, and hypotenuse. So I can't use those ratios. This C opposite side, I'll call this little c, and standing on B, this opposite side is little b. So again, this does not have to be a right triangle. It can work on any triangle. But there is area formulas that I can use. And these area formulas look like this. Even though it's not a right triangle, I can use these formulas to figure out the area. So the area is still 1/2, but now I'm going to have three different formulas. It's 1/2 the B side, this B value, times C value sine of this angle here, this angle A. So if you plug that in, that will generate the area. Same thing, it's very similar. It's 1/2 A times C sine B. So if I had this angle here, I could take 1/2 of AC and multiply it by the sine of C to get the area. And the third is if I have angle C. It'd be 1/2 A times B sine this value of C right here. So it's just another way to find area if I don't have the information that I'm used to. We'll actually do an example of that right now. I'll do a couple of examples and show you how it works. So let's look at example number 1. I'll draw you a triangle again. Oh gosh, not that one. That is too bad. That was not a straight line at all. I even had trouble erasing it. It was such a bad line. There you go. That's better. Okay, so if I knew this value was 8, and I knew this value was 12, and I knew this angle value was 86 degrees. Oh, that's bad, but whatever. A picture represents something. It doesn't have to be perfect. So as you can see, this is much more than 86 degrees, but I don't really care. I just need to know values. So let's just plug in, since I don't have value or letters for my vertices, let's go ahead and put them in. Now, it doesn't matter. This is not important. This is just to give you an idea of what A, B's, and C's are so that you know which of these formulas to use. So if I know B, I have angle B. So since I have angle B, that means I'm going to be using this formula right here. I have angle B, so it tells me that I'm going to be using this formula right here. So I'm going to do this. So let's go ahead and plug what we know in. So A and C, so opposite here, this is my little A. Opposite my C, this is my little c. Okay, so I've got this information. Let's go ahead and plug it in. So I would say area equals 1/2 little a. So little a is this 12. So I'd say times 12 times this little c is 8 times the sine of this angle. And that's an 86, believe it or not. So 86. So this is a calculator problem. So this is like, let's grab our calculator and start plugging it in. So all right, great. So I'm going to go sideways here because I want to use the sine cosine. I don't need that second, so I make sure that that's off. I'd like to clear it a couple times so I know that what I'm doing here is good. All right, and so now I'm just going to type in this 1/2. I know that's 0.5, so I'm not going to say 1 divided by 2. I understand that 1/2 is 0.5. So 0.5 times 12. In fact, if you wanted to do that in your head and say, what's half of 12 and go 6, you got my vote. Times 8 times, now I type this in, 86 sine, and then I push equals. And it generated a value for me. It said, oh, great, your area equals 7.98. That just doesn't seem right. Equals, let me try that again. 12 times 8 times 0.5 equals times 86 sine equals. You're right. I was totally wrong. Okay. So again, I told you that I often make a lot of mistakes. Here was one of them. I felt like that was too small, right? That this is 8 and this is 12 and this is almost 90. So it's really almost like base and height. It's got to be around 90 something, or no, half of that, around 70 or 45 or something. So I knew that that was probably wrong. So I retyped it into my calculator and I got the value 47.88. Now, this is a great strategy. Try it a couple of times until you can generate that 47.88, and then get familiar with how you're plugging it in that way. It is okay to get the wrong answer. I just did. I had an idea it was wrong, so I tried it again, and the answer I got, I said it needs to be around 45, and it was 47. I feel a little bit better about this. So I would really suggest making sure that you feel comfortable typing this in and generating these values. Okay, so let's do one more of these areas, and then we'll move on to law of sines. I'll generate a nice, well, that is actually, I was so good there for a second. All right, if this value is 2.96 and this value is 2.13, and I know this angle is 73 degrees. Now, if I did have different values in here, what if I had these labeled as G, you see, GH and I. What if I had these labeled as GH and I? It doesn't mean we can't plug it in and figure out what A, B, and C are. All you need to do is know which one is A, which one's B, and which one's C. Or if you want to know how I do it, I know that I use the other two sides besides the point. So I know that this G, since I'm going to be using the sine of 73, I notice that I'm going to be using these other two sides. So it's going to be 1/2 2.96 times 2.13 times that. That will be my area. But, if it helps you, just plug in and put one as A, B, and C. It doesn't matter which, and then you'll be able to figure out which formula it is. Okay, again, I'm going to plug this into my calculator. I had trouble last time. I hope I do better this time. So let me clear this and say 0.5 times 2.96 times 2.13 equals. I think that was my problem. I didn't put the equal sign. So equals. Now I'm going to multiply it by the 73 sign and push equals a second time. And it generates a value of 3.01. And I asked myself, does that make sense? 3.01. Well, this is almost 90. It's not quite. So if I multiply those two, 3, 6, half of that's 3. Yeah, it feels pretty good. Yeah, I feel okay. Okay, so let's move on to the idea of law of sines. So this is something that is true. It's a relationship that's true in triangles, and it really helps us find values of sides and angles that we don't know. Here is the law of sines. This is the law of sines. It says that if you take the sine of any angle in a triangle and make a ratio of it over its opposite side, that will equal the sine of a second angle in that triangle over its opposite side. And in essence, this is true for all three angles. So you could do it with the third angle and its opposite side. Those ratios will make proportions. So here's the value of this. Here's how this works. So write this down. We're going to be using this a lot. There'll be assignment that's dealing with this a lot. So I'm going to do 3, maybe 4 examples with this so that you get familiar with this. But if I have a triangle, let's become real familiar with a vertex and its opposite side. This angle and its opposite side. This vertex and its opposite side. This angle B and its opposite side. This vertex C or this angle C and its opposite side. So that's the key. Do we have an angle and its opposite side that we can make this ratio? Because if you have that, and we can have one of the other two pieces to the other side or angle, then we can use cross multiplication to find what's unknown. So let me show you how that works. Here in example 2. So I'm going to draw you another triangle. Again, notice that I don't care how I'm drawing. I'm just writing them up really quickly. I'll call this S, T, and U because it doesn't really matter. I will give angle S is 40 degrees. Angle S, angle U is 49 degrees. And let's say that the opposite of S is 20. And let's suppose I'm looking for the unknown pieces. Let's find this. Let's find this opposite. Actually, let's find this too. And heck, while we're out of it, why don't we find this as well? We'll call it T. And why did I call that X? I should have just called it U, but whatever. Okay, so let's start with the third of an angle of a triangle. Now, I know I just talked about ratios and proportions, but stop and ask yourself, what do you know about the 3 angles of a triangle? What do they always add up to? Never change. It'll always be true. Yeah, 180. They add up to 180. So if I know that the 3 angles of a triangle add up to 180, and I know 2 of the angles, well, if you subtract those 2 angles, then what's left over will have to be the third angle. So already we figured out the angle theta has to be 91 degrees. Well, because I subtracted 40 and 49 from 180. And when you did that, you got what's left over, what that angle is. So actually, you have this angle without doing any of this law of sines. But now let's use law of sines to figure out this unknown value right here. Well, I told you that if you know an angle and its opposite, that's the key. So I know the sine of 40, and I picked this because I know its opposite side's value. So it's critically important that we find the sine and its opposite. So sine of 40 over its value will equal, let's figure out this x first, sine of this angle, 49, and its opposite. I don't know that, but that's okay, because what do we know about a proportion? Yeah, that we can cross multiply and divide. So we can cross multiply these means and divide it by this value, and the answer will be x. So I'm going to do that now. Grab my calculator, try it out. So I'm going to say 20, sorry, come on, recognize me. 20 times 49 sine equals, okay, now I'm going to divide that by 40 sine, I have to do it in that order, equals, and it gives me a value. It says, hey, x is 23.5. 23.5. And I asked myself, does that make some sense? Well, I'm like, well, let's see. 40 degrees is a smaller angle than 49. So this side should be bigger then, because the bigger angle will have be across the bigger side. Yeah, and it's 20 and it's 25. Yeah, it seems pretty good. So I now got this. So let's figure out little t. Let's figure out it. Same way, I now know this value, so I can say sine, and we knew this theta now is 91 over its opposite, I don't know, t, will equal, and it doesn't matter which we pick. I'm going to pick this one because it's whole numbers, so I don't need to worry about any estimation. So I can say sine of 40 over 20. But you could have said sine of 49 over this x value, which is 23.5. I multiply the extremes because they're the two values, and then I get an answer here. All right, so let's see what we get. Let's take 91 sine times 20 divided by 40 sine equals, and it gives me 31. Okay, great. Let's go on to example number 3. Give me another triangle here. (141), 23. And I'll give you a value here of 9. Let's see if we can figure out this angle, this value here, and this value here. So if I know these angles, then I can say 141 plus 23, take that out away from 180, because this is how we find the third angle, 16. So I figured out theta is 16 degrees. So now we can do this. Let's go sine of 141 over, no, I don't want to do that. Oh, sure, over b, I don't know what, equals, now I can say sine of 16 over 9. I'm going to go ahead and do this. Recognize me. Okay, thank you. So I'm going to say 141 sine times 9 equals, divided by 16 sine equals 20. So b is 20. And let's try a now. We're going to just incorporate a, which is the sine of 23 over a. So again, I'm going to do I did this cross here first. This time I'm going to go, this time I'm going to go this cross first. So I'm going to say 23 sine, is it 23? Yeah, times 9 equals, divided by 16 sine equals. And it says 12.8. So that is my a value. A is 12.8. Great, and I think I have, I think I got A, B, I got everything I need. Excellent. All right, I actually have 2 more to go. So let's go through these. Number 4, again, I'm just going to draw my triangle. this will be given to you, so you'll have this information. 107, 12. So now we have an angle and its opposite, so we know we can do this. 42. Let's find this angle. Let's find this side here. Let's find this side here. So let's start with this angle. 107 plus 42. Subtract that from 180. So we now know that theta equals 31. All right, so let's figure out the law of sine. So we're going to say sine of 107 over 12 will equal, let's try x first. Sine, and what is the opposite of the x? 31 over, I don't know. So let's do my cross multiplication. So I'm going to say 31 sine times 12 equals divided by 107 sine equals. All right, so I got a value of x is 6.5. That's estimated, of course. I'm going to do the same law of sine. Sine of 107 over 12 equals, this time I'm going to say 42, or sine of 42. I will tell you the mistake most people make is they forget the signs. They think it's 12 times 42. Make sure that we put in sine of 42. So you realize that sine of 42 will generate a fraction or a value. So if I said 42 sine times 12 equals divided by 107 sine equals, and it tells me it's 8.4. So that last value that is y, 8.4. Great. Last one. Actually, I'm going to skip that last one. Great. Listen, you did a nice job. Make sure you get those notes in, turn it in to me, and let's see how things are going. Good luck.